welcome to Lesson 6-2. If you remember back to Lesson 5-1 when we first started digging really deep into these quadratics, we showed you guys how to graph from intercept form. Now you've probably realized by now through the different problems that we've done is that a lot of times you won't be given the quadratic in your intercept form. So what we are going to do in these next two lessons, in Lesson 6-2 and 6-3, is to show you two other ways that we can graph it, two other forms that we can graph from. And then in 6-4, once we have familiarity graphing with all three methods, we're going to show you how to change it back and forth between the forms so that you can get it to whichever form you like to graph it with. In this lesson 6-2, we're going to focus specifically on graphing from standard form. If you remember from our last lesson, 6-1, in our solving by the quadratic formula, our standard form for a quadratic is the y equals ax squared plus bx plus c. We needed it in this form to be able to plug it into the quadratic formula in the last lesson, so we're going to go ahead and continue with that form and show you how to graph it from that form. So the first thing you're going to need to do is to put the equation in standard form. You'll need to get all the terms on the same side of the equation. You need it to be ax squared plus bx plus c. The next thing you're going to do is to identify the values of a, b, and c. And we got practice with this in lesson 6-1 because we needed those three values to plug into the quadratic formula. The next thing we're going to do is to find the axis of symmetry. Now this is where things are a little bit new. Our way that we're going to find the axis of symmetry is we're going to take negative b over 2a. So we're going to plug in values kind of like we did with the quadratic formula, but we're using a lot shorter version that's going to help us find the axis of symmetry. And what we're going to do after that is to make a table of x and y values, just like we were doing with our graphing from intercept form. We're going to want a total of 5 points, and we're going to plot the points and connect them with a U-shaped curve or parabola and arrows. Now we have discussed this before, but remember that if a is positive, the quadratic function will open up, and if a is negative, the quadratic function will open down. So we do have a couple tips for you guys on how to choose your 5 points. The first one is going to be using the x value from the axis of symmetry, and you're going to put that in the center of your table. This point will be your vertex. Always use 0 as one of your points. This will give you your y-intercept. So far we've talked about vertex, y-intercept. And then also, remember that your axis of symmetry serves as a reflection line. Every point you calculate will have a mirror image on the other side of this line. And we talked about that some in intercept form as well. So let's go ahead and jump into an example. That way we can see this hands-on. So we are given example 1, y equals 2x squared minus 4x minus 2. So the first thing we'll want to do is to go ahead and identify our a, b, and c. Our a is going to be 2, our b is going to be negative 4, and our c is negative 2. Now we can already tell before we even graph this whether it's going to open up or down. We looked up at the tip earlier. Our a value is positive, so this is going to open up. What we need to do now is to find our axis of symmetry. Now remember, for your axis of symmetry, we are going to need to do negative b over 2a. So we're going to do negative b over 2a. In this case, it was going to be a negative 4 over 2 times 2. And I'm just pulling our a, b values from what we've talked about over here. So when we simplify this, that's a negative is going to give us a positive. And on the bottom, we're going to have 2 times 2, which is 4. So I simplify this and I get 1. So my first value that I'm going to plug in the center of the table is going to be 1. And my axis of symmetry I can go ahead and fill in is x equals 1. Now we know this is going to be the x coordinate for a vertex, but what we're going to need to do now is to find what that vertex is. So what I'm going to do is I'm going to plug that in to my original equation. So everywhere I see an x, I'm going to replace it with a 1. So when I simplify this, one thing that is important, follow your order of operations. That will be one place where people mess up. And the other thing is make sure that you're paying attention to your signs. If you are plugging in a negative, make sure that you put parentheses around that so that you know that you have to include that negative when you're doing your calculations. So, order of operations, first thing we need to do is our exponents. 1 squared is 1, so we're going to have 2 times 1. Minus 4 times 1 is going to give us 4, and then minus 2. We simplify here, 2 times 1 is 2, minus 4, minus 2. So when I plug this in, figure it out, 2 minus 4 is negative 2, negative 2 minus 2 is negative 4, so I now have my first point at 1, negative 4. And I am going to go ahead and plot that on my graph. I'll go put it right there. Alright. Now, what I usually do from here is to go ahead and plug in the points above and below that vertex. That way I know that I'm going to have a mirror image. So we did say in our tips that 0 is a good thing to plug in. That way you have your y-intercept. So that's what I'm going to do next. Before I do that, let's go ahead and fill in the rest of our vertex over here. Our vertex is going to be a negative 4, so I'm going to fill that in. And we can also tell whether it's going to be a max or min from whether it opens up or down. We said earlier it's going to open up, so that means it's going to have a shape like this. So that means that that is going to be a minimum. And we'll talk about those other characteristics as we come to it. But next we're going to go ahead and find our y-intercept. We do that by plugging in 0 for x. So I'm going to use that same original equation, y equals 2. But instead of putting an x this time, or putting a 1, I'm going to put in my 0 for my term that I am plugging in for. So that's going to be 2 times 0 squared minus 4 times 0 minus 2. So zeros are very nice to work with. 0 squared is going to be 0, and 2 times 0 is going to be 0. Negative 4 times 0 is going to be 0, and I'm just left with negative 2. So y is going to be negative 2, and that gives me my y-intercept. So I can actually go ahead and plug this part in here, 0, negative 2. And I can also add a point to my graph, 0, negative 2. Alright, and it doesn't look like my last point stayed, so let me regraph that one as well. We had 1, negative 4 earlier. Alright, now, we talked about how the axis of symmetry is a line of reflection. So we can take our point here and reflect it over our axis of symmetry to the right. Remember, the axis of symmetry goes through our vertex. If you're looking at our new point compared to the axis of symmetry, it moved over 1. So we're going to move over 1 the other way and fill in the dot there. This computer really does not like to put fine little dots there. Alright, so we already have 3 points, so I'm going to go ahead and fill this in as negative 2 because I know that these are going to have to reflect as long as this is my vertex in the center. So that means we're going to have to find 2 more points. So to do that, I'm going to just plug in these values that I have here. So just so we have some work with some negatives, I'm going to go ahead and pick negative 1 as the next thing I'm going to plug in. So I'm going to again go back to my original equation. This time I'm going to plug in my negative 1 for x. So I'm going to have 2 times negative 1 squared minus 4 times negative 1 minus 2. So we can go ahead and simplify this. We do our exponents first. Negative 1 squared is going to be a positive 1. Remember, if you put this into your calculator, make sure you put parentheses around that negative so that it follows the order of operations correctly. Then we're going to have minus 4 times negative 1 minus 2. We do our multiplication. 2 times 1 is 2. A negative 4 times a negative 1 is a positive 4. And then we have a minus 2 at the end. So finally, we can go ahead and finish the rest of this. 2 plus 4 is 6, and 6 minus 2 is 4. So we now have a point at negative 1, 4, and 3, 4, because we know that these are going to reflect. So I'm going to go ahead and plot my points, negative 1 and 4, and 3 and 4. And if I didn't use the table to help me figure out what this one was going to be, as soon as it will let me graph it, I could have counted over from the axis of symmetry that I went over 1, 2, and I'm doing the same here, 1, 2. So our very last step is to connect this using a U-shaped curve. So I'm going to do the best I can on this. Alright, it is a lot harder to draw these than straight lines. Alright, and then we did have a few last questions to answer. Our roots are going to be, remember, the same thing as an x-intercept. Now, with these graphs, we're going to be okay if you're pulling it straight from the graph to do a little bit of estimating. So I'm going to look where these cross. It looks like this crosses between 2 and 3. So I'm going to say maybe about 2.2. Remember, these are x-intercepts. So I am going to have 2.2, we'll say. And then our y value will, of course, have to be 0. And then on the other one, it's between 0 and -1. So I'm going to say about -0.2, comma 0. Now, we can be a lot more precise on this. I'm not going to spend the time in the video doing that, but there is a more precise way to do that, and that is to use the quadratic formula we used in 6-1. So if this were a standalone problem and you were just asked to give the roots, I would expect you guys to use the quadratic formula to figure out exactly what those roots are. But since our main focus on this is the graphing, we're more worried about you getting the graphing down and reviewing the characteristics. You can use estimation on your graph. Now, the last thing we have to talk about is domain and range. If you remember from Unit 3 and a little bit from Unit 5, we talked about this. The domain for any quadratic function that is not restricted is going to be all real numbers. So we can use that little funky looking R. We can write out in words all real numbers. We can do interval notation, or we can do set notation. It doesn't matter. Now for the range, remember, it's going to start at the vertex, which our y value was -4. And we are opening up, so we want all the values above -4. So our range would be y is greater than or equal to -4. Alright, we have one more example to take a look at. Alright, so looking at example 2, the first thing I'm going to want to do is to go ahead and pull out my a, b, and c values. My a value is going to be -2, my b value is going to be 4, and my c value is going to be 1. So I'm going to go ahead and look at whether this should open up or down. That way I know if I'm on the right path when I do start graphing this. Our a value is negative this time, so that means it is going to open down. And then the next thing we need to do is find our axis of symmetry. So remember, we're doing that by -b over 2a. And I'll write that over here just one more time for us to remember. This time it's going to be negative. Our b is 4. And then our a is -2. So we'll do 2 times -2. We have -4 on top and a -4 on bottom. So this is going to give us a axis of symmetry of x equals 1, and I know that that's going to be part of my vertex, so I'm going to go ahead and put that in the center of my table, as well as on the line where it's asking me for my vertex. The next thing we need to do is to find the y value for that vertex, so we are going to plug that into our original equation. So we're going to do y equals -2 times 1 squared plus 4 times 1 plus 1. We are going to simplify. 1 squared is going to be 1 plus 4 times 1 plus 1. So we have y equals -2 plus 4 plus 1. When we combine these together, a -2 plus 4 is going to be a +2, and a +2 plus 1 is going to be 3. So I'm going to have a vertex at 1, 3. I'm going to fill this into my chart, and then I'm going to plot this point on the graph. So I go to 1 and then up 3. So that gives me my center point. We did talk about how this is going to open down, so this is going to mean that this is a max, because if it's opening down, our vertex will be on top. And then we can go ahead and fill out the rest of our table. So again, I would suggest moving from that vertex and going 0, 1, and then up to 2 and 3. I am going to go ahead and use my 0 because that is going to give me my y-intercept, and that's something that I am asked for later on here. So I'm going to go ahead and plug this in. Y equals -2 times 0 squared plus 4 times 0 plus 1. Now 0 squared is 0, and negative 2 times 0 is going to give me 0. 4 times 0 is also going to give me 0, so I'm going to have just plus 1, so my y value is going to be 1. So my y-intercept is at 0, 1. I'm going to put a little dot there. I'm also going to fill that in on my y-intercept down here. And I know that this is a line of reflection as my axis of symmetry, so looking at that axis of symmetry, I counted over 1. So I'm going to count over 1 the other way, which is going to give me a point at 2, 1. So I'm going to go ahead and fill that in my chart here as well. Sorry, those keep popping up. And then I am going to find my next set of points. So I'm going to plug in the negative 1. So I'm going to plug in y equals negative 2 times negative 1 squared plus 4 times negative 1 plus 1. Following my order of operations, negative 1 squared is going to be a positive 1. Then we are going to list out the rest of what we have here. And then I'm going to do my multiplication. Y equals a negative 2 minus 4 plus 1. So y equals negative 2 minus 4 is negative 6. And negative 6 plus 1 is negative 5. So I'm going to go ahead and plug in negative 5 on my y chart. I am going to go ahead and plot these points. So I have negative 1 and then down 5. And I'm going to put the dot. And then, once that dot finally shows up, I am going to count over from the axis of symmetry. My axis of symmetry was x equals 1. So I went over 2 to the left. So that means to plot the other point, I'm going to go 2 to the right. Last step is to go ahead and connect these. Let's see. Oops. It's really wanting to mess with me in this video, so sorry for that. But we're going to go ahead and connect these. And then we connect it down the other side. And then we want to finish asking or answering our last questions. Alright, this is a rather thick line, so yours will probably be a little bit more precise on this, but your roots should be somewhere between 0 and negative 1. I'm going to say negative 0.1, and then it should be just a little bit past 2. So I'm going to let me back up. Scratch that. I'm going to go ahead and erase that. Alright. And then I'm going to go ahead and look at my roots. It should be between 0 and negative 1. We want our x value first. I'm going to say that's about negative 0.10. And then it's also going to be just a little bit past 2. So I'm going to say about 2.10. Again, from the graph, it's going to be an estimation. If you were asked specifically to focus on the roots, you would want to plug that into the quadratic formula to help you out. Last thing, domain. Again, our domain is going to be all real numbers. I'm just going to write it a different way this time so you can see it. I'll write it in set notation. We go from negative infinity to x to positive infinity. That's the same thing as saying all real numbers. And then the range, our vertex value is going to be a 3 at the top. And then we want all the values below it. So we're going to have y is less than or equal to 3. Last thing I'm going to just do is go ahead and fill in the rest of this chart. Remember, these are just reflections. As long as you have your vertex in the middle, those should come out to be the same thing. Alright, that wraps up example 2. You guys go ahead and do the U-tries, and then go ahead and start the practice and let us know if you have any questions. See you guys next time.